Today I will talk about multi-criteria decision making. This is part of my series of lectures on decision making. I will also describe the use of fuzzy mathematics in multi-criteria decision making. First, I will give introduction. Then I will talk about applications of multi-criteria decision making. Then I'll talk about nomenclature, especially decision matrix. Then I'll talk about steps of multi-criteria decision making. Then I'll talk about different methods of multi-criteria decision making. Then I will give examples of Python code of various methods of multi-criteria decision making. Decision making is a complex process. It is a problem-solving process that aims to determine a desirable result considering different aspects. It is influenced by several factors, that is physiological, biological, cultural, social, level of authority, and level of risk. Multi-criteria decision making, or MCDM, is first described by Benjamin Franklin. MCDM methods consider different qualitative and quantitative criteria that need to be evaluated to find the best solution. Here, different weights provided by the experts may decide the importance of each criteria. Weights may also be determined mathematically, for example, using analytic hierarchy process. Applications of MCDM. MCDM has various applications in healthcare sector, energy sector, engineering and production, career and job, supply chain management, organizations and corporates, education, transportation, civil engineering, finance and economics, to name a few. Alternatives are different possible courses of action. So alternative is defined as a set of AI, where I is from 1 to m. Here A is a distinct and finite set of alternatives, and m represents the number of the alternatives. Criteria are defined as tools for evaluating and comparing alternatives from the viewpoint of consequences of their selection. It is defined as a set C with elements Cj, J is from 1 to n. Here C is a set of certain criteria that are used to evaluate alternatives, and n is the number of criteria. Weights is defined as a set W with elements Wj, J is from 1 to n. Here set W is a set of normalized weights assigned to each criteria based on their importance. So this is a MCDM matrix or a decision matrix. These row headers are various alternatives from 1 to n. The column headers are various criteria from 1 to n. And Xij are the elements of the decision matrix. Now, steps of multi-criteria decision making. Identify and select the criteria. This is the first step. Second is determine the weights of resources, either using expert opinion or by using mathematical methods. Then rank the resources by using a suitable MCDM method. This figure I have taken from this article. Then different methods of MCDM. Different methods of MCDM can be classified according to complexity level of algorithms, weighing methods for criteria, way of representing preferences evaluation criteria, uncertainty of input data, data aggregation types. So multi-attribute decision making, here there are discrete number of alternatives. Multi-objective decision making, here there is a continuous problem decision making. So MCDM can be classified into multi-objective decision making and multi-attribute decision making. This is from this article, this figure. Then it can also be divided into individual decision making and group decision making. So there is slight alteration in methods for these two. types. Then it can also be divided into certain input data and uncertain input data. For uncertain input data, we use fuzzy MCDM methods. So these are some of the MCDM methods. So analytic hierarchy process is a pairwise comparison of hierarchical criteria considering difference information. Then these are others. The common one is TOPSIS, evaluating based on the distance of alternatives to the ideal solution. So we find in TOPSIS an ideal best and ideal worst solution. Then CBR is case-based reasoning. It is making recommendations using the analysis of historical data. Then there is fuzzy type of ASP method. Then there is VCOR method here, which is a compensatory version of TOPSIS that is based on minimizing the distance to the ideal solution using a linear normalization approach. Then there is a fuzzy variety of TOPSIS. Then there are these other various methods. Then let us see what is analytic hierarchy process or ASP method. Let us say that we need to decide and select one of our raw material supplier from a total of 3 available suppliers. So this is an example I will take throughout my lecture, and I will use various methods of MCDM to find the solution of this problem. So in this example, we will assess these three suppliers on the basis of 4 criteria. First criteria is turnaround time or lead time of supply, then discount offered, then cost and quality. So AHP include hierarchy. So first of all, there is goal, followed by the various criteria. So I have these 4 criteria in my present example, and there are these 3 suppliers for each criteria. The decision matrix as defined previously as elements X, I, Z. So for my present example, this is the decision matrix. There are 3 alternative suppliers, supplier 1, 2, 3, and these are 4 criteria. The turnaround time for supplier 1 is 3 days, for supplier 2, 5 days, and then 2 days. The discount is 10% for supplier 1, 15% from supplier 2, and 6% from supplier 6. And then this is the cost and this is the quality. So here the 2 criteria, discount and quality, are beneficial criteria, where the more the better. And the turnaround time or lead time and cost, these are non-beneficial criteria, smaller the better. So these things should be kept in mind while doing calculations. Then we have criteria matrix. We have criteria along the rows and along the columns. So this is a square matrix. The elements are E, I, J. And we fill the matrix as turnaround time is equally important to turnaround time. So we fill 1 here. Turnaround time is 3 times more important than discounts. We fill 3 here. Similarly, we fill other elements. And this is the basis of filling. 1 is for equal importance. 3 is for moderate importance, 5 is for strong importance, 7 is for very strong importance, 9 is for extremely important, and there are middle values also like 2, 4, 6, and 8. And since this is a square matrix with the diagonals as 1, so we fill the entire matrix like this. So turnaround time is 3 times more important than discount. So discount is 1/3 more important than turnaround time. Then we normalize the criteria matrix. And this is the formula for normalization. This is our normalized matrix. Then we calculate the total of the rows, and then we calculate the average. So this is our criteria vector. We also need to check the consistency of our criteria weights. So for this, we take matrix of criteria importance, square matrix, and then we calculate the weighted sum along the rows. Then we divide each weighted sum by corresponding weights and we calculate the mean. And by further calculations, we get the consistency ratio as 0.11, and it ideally it should be less than 10% or 0.10. Then after obtaining weights, we can assess the suppliers. So this was our original matrix. And so we calculate the minimum and a maximum for each column, maximum for beneficial columns and minimum for the non-beneficial columns. And then we do further calculations. Then we multiply it by weights and we calculate the sum. So this is our result. The supplier 3 is the best supplier, followed by supplier 1 and then supplier 2. This is important because according to our weights, more of the weight was given to turnaround time. So turnaround time was least for supplier 3. Hence, our supplier 3 is the number one supplier in ranking. So this is on one criteria turnaround time, but our method has considered all the criteria together. Then Topsys method. This is the short form of technique for order preference by similarity to ideal solution. So here we have a decision matrix. Then we calculate the sum of squares of each column. Then we take square root of sum of squares. Then we divide each element by sum of squares to get the normalized matrix. Then we multiply each element by weight to get the weighted matrix. And then we identify the best and worst value. So for a beneficial criteria, for example, discount, the best situation is 0.118. That is the maximum of these three. Whereas for non-beneficial criteria, the best scenario is the lowest, that is 0.183. So this is the best scenario and this is the worst scenario. Then we calculate the Euclidean distance of these values from the best and worst scenario. So these are the Euclidean distance from best and these are the Euclidean distance from worst. Then we calculate the preference. So supplier 3 is the most preferable supplier, followed by supplier 1 and then supplier 2. The results are very similar to ASP example as we have seen before. So Topsys is also giving similar results. So this is the summary of Topsys method. We first calculate the normalized matrix, then we calculate weighted normalized matrix, then we calculate ideal best and ideal worst value, then we calculate the Euclidean distance from the ideal best and worst, and then we calculate the performance score. Then let us see Python codes using AHP and Topsys method as well as fuzzy Topsys. So this is AHP analytic hierarchy process. So I will use Python codes to determine the weights. So this is the library. These are the basic libraries NumPy and Pandas. So first of all, now let us read the importance of criteria pairwise. So this is the importance of criteria 1 over criteria 2, that is 3. This is the importance of criteria 1 over criteria 3, that is 7. This is the importance of criteria 1 over criteria 4, that is 5. And similarly. Then this is the calculation of weights. So these weights are similar to the weights which we have calculated manually before. There is slight alteration because of rounding up in Excel calculations. Then Topsys method using Python. These are the basic libraries NumPy and Pandas. So this is the data input. So this is our decision matrix, which has been converted into a data set. These are about these are our weights as calculated before, and this is the impact, that is minus for non-beneficial criteria and plus for beneficial criteria. So this is for normalization in Topsis method. This is the normalized decision matrix. This is the calculation of best and worst scenario. So this is best scenario, this is the worst scenario. Then these are further calculations of Topsis score. And we have ranked our alternatives. The supplier 3 is ranked 1, followed by supplier 1 and then supplier 2. So these results are very similar to previous results which we have done manually. Now about fuzzy Topsis method. For this I have taken different data. So here we have a library known as PyFDM. This is important library for fuzzy decision making. It includes various methods for fuzzy decision making. So this is our decision matrix and these are the weights. So weights are also fuzzy and decision matrix elements are also fuzzy. And these are the types. Types corresponds to the beneficial and non-beneficial criteria. So there are three criteria, 1, 2, and 3. And these are alternatives, 1, 2, 3, 4, 5. So there are 5 alternatives and 3 criteria. These are 3 fuzzy weights for the 3 criteria, and these are the types. There are 2 beneficial criteria and 1 non-beneficial criteria. So this is simple calculation, straightforward. So these are the ranks of our 5 alternatives. So this is all for today. Thank you very much.